In this video, I'm going to show a couple more examples of using the chain rule to find derivatives. So I guess the first thing I would do is always identify what's the inside function, because remember, chain rule is for compositions of functions. So I look at this and I say, well, the 5x squared has been put into cosine. So I'm going to treat that as my inside function. So f prime, the derivative of the outside, so the derivative of 2 cosine of something is negative 2 sine. I'm going to put some parentheses. Now, the inside function stays exactly the same. It's still 5x squared. And then I multiply by the derivative of the inside, which is 10x. So if I clean this up a little bit, negative 2 and 10x, I got negative 20x times the sine of 5x squared. And this is my derivative. Okay? Next, in this next problem, f of x equals 6x squared minus 8 to the 6th. My inside function is 6x squared minus 8. That's all being raised to the 6th power. So my derivative I start by bringing that 6 out front and then dropping the power to the 5th, just like I always would. And I leave the inside alone. And then I multiply by the derivative of the inside, which is 12x. And I could clean it up a little. 6 times 12x is 72x. 6x squared minus 8 to the 5th. And this is my derivative. Now this next problem, I would start by doing a little rewriting. Okay? I would rewrite this as 4 multiplied by 7x minus 5 to the negative 1/2 power. Because of course a 1/2 gives us the root. The negative is what would have put it in the denominator. Now what this does, it creates a really nice it gives me a really nice way of just using power rule. If the numerator were a function that wasn't a constant, if it was 4x, I would probably just use quotient rule. But because it's a constant, I can use power rule really easily. But again, if it were some function with x's, I would just use quotient rule here, because I don't want to bring them up and then have to do, bring the denominator up with a negative exponent and then have to do product rule. That's not worth it. Okay. 7x minus 5 is going to be my inside function. So 4 multiplied by negative 1/2 is negative 2. Now it was negative 1/2. If I drop the power another 1, I get negative 3/2. I leave the inside alone. And then I multiply by the derivative of the inside. So I have 7x minus 5 to the 3/2 power on the denominator, and I have negative 14 in the numerator. Now in that denominator, let me just point this out. If you wanted to write this with a root instead, remember in a fractional exponent the power is on top and the root is on the bottom. So you could write this denominator as the square root of 7x minus 5 cubed. And that would be maybe a nicer way to write it, since the original problem had a root in it, but this works as well. Let's look at a couple more examples. In this example, sine of 3x squared cosine 5x, I hope you notice that we are going to need product rule, right? We've got this function multiplied by this function. And within our product rule, we're going to need chain rule, because we've got 2 inside functions. Okay? So, f prime. Remember, your product rule is the first times the derivative of the second. Now, think about chain rule here, right? We've got a 5x on the inside, so we start with the derivative of the outside, leave the inside alone, and then multiply by the derivative of the inside. plus. So that's our first times derivative of the second. Then we've got the second times derivative of the first. Well, again, we've got to think chain rule. We start with the derivative of the outside. So we've got the cosine, 3x squared. We leave that inside alone. And then multiply by the derivative of the inside, which is 6x. Now, I could clean this a little. Of course, we usually like to have numbers go up front and trig stuff come last. So I could write it this way. I guess it would be negative. In terms of combining your cosines and your sines, you actually can't. And the reason you can't is because what's inside them is not the same. Okay? So you can't multiply these together because it's the sine of 3x squared and the sine of 5x. So you can't put those together. All right, this next one I'm going to rewrite. I'm going to start by writing it as x squared plus 5x minus 2 to the 1/2 power. So my inside function, of course, is going to be this whole thing. So my derivative, I bring the 1/2 up front, and I drop the power to negative 1/2, right? Subtract 1. Leave the inside alone, and then multiply by the derivative of the inside. Now, what ends up on the denominator? Well, we've got a 2 from that 1/2, and we've got the x squared plus 5x minus 2 to the 1/2, but I'm going to write it with a square root. I'm going to say it's x squared plus 5x, or the square root of x squared plus 5x minus 2. And what's left on top is a 2x plus 5. So there's my derivative. All right, last one. I'm going to rewrite this as 4 times x minus 5 to the negative second. And again, I do that because the top is a constant. If it weren't a constant, I would use quotient rule. So we multiply 4 by negative 2, and then drop the power, leave the inside alone, and then multiply by the derivative of the inside, which is just 1. So I end up with negative 8 over x minus 5 cubed. So just some examples on chain rule.